In episode 16 of the Junior PenTester training series, we are going to go through SQL injection vulnerabilities and those types of attacks. And this is actually the last video in the web hacking portion of Junior PenTester. And we're going to be talking about how to exploit the structured query language databases, SQL databases, how to get access to information that we should not have access to. And of course, we're going to run through some practical exercises and remediations, all that good stuff. My name is Hackaholics. I will be your trainer for today, and we're using the TryHackMe platform. Now, this particular room that we're in is actually a free room inside of TryHackMe, which means that anybody that's inside of this room with a free member account, you can go ahead and deploy the virtual machine. You can run through all the exercises that we're going to run. So really exciting, really cool. And I'm so glad that it's actually this room that's one of the free ones, because SQL injection is a really cool freaking attack that you can do if you learn how to actually do it. So as a part of the contents of this video, as an overview, we're going to talk about what an SQL database actually is, or we should say, what is a database in general? Then what's SQL, right? The structured query language. And then what is SQL injection? We're going to talk about in-band SQLi, blind SQLi, and of course there's different versions: authentication bypass, Boolean based, time based, and then out of band SQLi, and then of course how to remediate it. Shout out to Logic. I want to say that's how you pronounce it. It's like Logic or Logic, whatever. That guy, or person, I should say, that person, for creating this room for us. Shout out to TryHackMe for allowing us to use it for free. I love TryHackMe. I've learned a lot from these people, and I highly recommend that you go create your own free user account so that you can get access to rooms like this. There's like hundreds of free rooms inside of TryHackMe. And then of course there's the paid subscription, which is totally worth it. And I encourage you to get that as well. All right, quick little note from Hackaholics Anonymous, and we'll jump into it. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into SQL injection. All right, for a quick brief, SQL, so the structured query language injection, is mostly referred to as SQLi, and it's an attack that you do on a web application's database server, and it causes malicious queries to actually be executed, right? So you can actually pull information about their customers, the customer usernames and passwords and credit card numbers, whatever, right? So when a web application communicates with the database using input from a user, so there's a form, a search box or something that you can input something into, and it has not been properly validated, there runs the potential of the attacker being able to steal, delete, or alter private and customer data, and also attack the web application authentication methods to private and customer areas to actually gain access to those areas. And this is why SQLi is one of the oldest web application vulnerabilities, because databases have been around for a very long time, and they've been housed pretty much as long as the website had a list of users. Databases were around since then. So you can imagine, like, I mean, pre-MySpace, like, I don't know what it was, but there was definitely very old websites that allowed people to create user accounts. As soon as you create a user account, you go inside the database in the web application server or in the web server, and then from there, that's where the database is built, and then now you can do SQL, or the system will actually run SQL queries to pull certain pieces of data. So SQL is actually something that's done in a lot of different contexts, and the web application server itself will actually submit SQL queries to be able to pull information from the database to allow people to come in or whatever. So what we're going to learn is what databases are, in case you don't know, what SQL is with some of the basic commands, and how to detect those types of vulnerabilities, how to exploit those types of vulnerabilities, and of course, how to protect against those vulnerabilities, because that's kind of the end goal here. It's not just to attack, but it's to actually find out how to prevent other malicious people from attacking us. So what does SQL stand for? It stands for the Structured Query Language. Now let's talk about what a database is. So if you've never used a database, or if you've not worked with a database before or exploited them, there's terminology that we need to get adjusted to, and this is why we're doing this. So what is a database? And it's a way of electronically storing collections of data in an organized manner. It's a database. It's controlled by a database management system. And DBMSs fall into two camps. You have relational or non-relational databases. And the focus of this video is the relational databases, meaning that there are multiple databases that could actually relate to each other. They have relationships with each other, and they can pull data from each other to check whether or not a user exists, what the various attributes of those users could be, what the various data sets are stored inside of these for each individual user, right? So some of the common ones that you'll actually run across, which you may have already heard of, would be MySQL, Microsoft SQL Server, there's Access, PostgreSQL, SQLite. All of these things are relational database management systems. So we're going to be talking about the difference between these in a little bit. But within the DBMS, we can have multiple databases, as I kind of explained, or I just explained it to you, I guess. And each one of those databases contain their own sets of related data, hence relational database. So for example, there could be a database called Shop. Within it, you would have information about products to purchase, and then users who have signed up to the shop, and information about the orders that they've received. You'd store that separately in the database using something called a table. So inside of each database, there could be multiple tables. The tables are identified with a unique name for each one, and you can in this specific diagram, we can actually see it. So let me see if I can kind of get you to see this easily. So this is the database server. Then there's the shop database, there's the staff database, there's the accounts database. Inside of each one of these, there are multiple tables. So inside of the shop database, there's the users table, the products table, and the orders table. Inside the staff, there's the users table, the information table, and the audit table. Inside the accounts, there's the customers accounts, orders, and payroll table, right? So these are a bunch of different ways, and you can see how it's all organized, right? It's structured. And this is what a database actually looks like. So what are these tables? Now, a table basically has a bunch of columns, and each column represents a set of data. So each column has rows. I mean, this is like, if you've seen a spreadsheet, this is easy stuff to wrap your head around. So if you imagine it, it's like a grid with the columns going across the top from left to right, containing the name of the cell, and the rows going from the top to bottom, with each one having actual data. So this is an example. These are our columns. We have the ID column, the username, and the password column. And then each row, so ID 1 will have John and his password. ID 2 will have admin and his password. And then so you'll see this. This is a row, and then each one of these is a cell. And this is basically a spreadsheet. So you should be very familiar with this. If you're not familiar with a spreadsheet, you got to go get familiar with Google Sheets and Microsoft Excel, all that stuff. So each column, better referred to as a field, has a unique name per table. When creating a column, you also get the type of data that will contain someone's being integers or numbers, someone's being string, which is standard text, or dates. Some databases can contain much more complex data like geospatial, which contains location information. Setting the data type also ensures that incorrect information isn't stored, so this is actually a part of security here, such as the string hello world being stored in a column that's meant for dates or for integers. If this happens, the database server will usually produce an error message. A column containing an integer can also have an auto increment feature that's enabled that will just go up by 1, for example. So ID starts with 1, the next user that's created gets an ID of 2, the next one gets an ID of 3, like that. It auto increments. This gives each row of data a unique number that grows incrementally with each subsequent row. Doing so creates what's called a key field. A key field has to be unique for every row of data. So each user should only have a unique ID, right? That's basically what makes us ensure that we don't have multiple users having the same ID. and it can be used to find exact row in SQL queries. So if you know somebody's unique ID, you should be able to pull all of their data by just knowing their unique ID. A row is also known as records containing individual lines of data. When you add data to the table, a new row or record is created. And when you delete data, a row or record is removed, right? So the table, or excuse me, the column is referred to as a field because when you look at the data that you're pulling information from the ID field. You're pulling information from the username field. And so John's ID would be pulled from the ID field for the user John, and it will get the value of 1. For the username field for ID 3, we'll be pulling Martin, etc. So hopefully that kind of makes sense. Relational versus non-relational is something that we need to have a good grasp on. Relational databases store information in tables, and often the tables share information between them. And these use columns to specify and define the data that's being stored and the rows that are actually storing that data, right? So the tables will often contain a column that has a unique ID, which is the primary key, which will then be used in other tables. So for example, a table for the user accounts will have all their unique IDs, but then the table for purchases will also track everything based on the unique IDs, right? So the unique ID for Martin will exist in the username table, and it also exists in the order table. And then from there, any purchase that Martin has made will be tracked to his user profile using his ID. And it can be used to cross-reference across multiple tables, right? So, which actually creates a relationship now. So if you can cross-reference data from multiple tables, that means that the data points, my God, my brain just farted. Those values inside of those tables now have a relationship with each other. That's so weird that like that happens. Like literally my brain crashes. The Windows theme, doon, 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 like that literally happens in my brain. So hence the name relational database. Non-relational databases, sometimes called NoSQL, are any sort of database that doesn't use tables, columns, and rows to store the data. A specific database layout doesn't need to be constructed, so each row of data can contain different information, giving more flexibility over a relational database. Some popular databases are MongoDB, Cassandra, and Elasticsearch. So these are non-relational, okay, which actually gives more flexibility because they don't have to now match the various fields or the key fields to be able to meet the criteria of all of the other tables and for them to be able to coordinate with each other. So now that we actually understand this, we can learn how to talk about using that language, the SQL language. So what is the acronym for the software that controls the database? That is a database management system, DBMS. What's the name of the grid-like structure? That would be a table, and that's it. All right, so what's SQL? SQL is the language basically for databases. It's feature-rich and it's used for querying a database, basically pulling data from the database, making adjustments to the database, and the queries themselves are referred to as statements. Okay, so you'll see why it looks the way that it does once we actually see like a full query. It's kind of a full statement that you're creating to interact with the database. The simplest of these is going to be select. So you're selecting data from the database. Update will be updating the data in the database. Inserting is inserting data into the database. And of course, deleting will be deleting data from the database. So some databases have their own syntax and slight changes to how things work, but these are all based on MySQL or the MySQL database. After learning these, you'll be able to search for alternative syntax online for the different servers, because they're very similar to each other. They may have like nuanced differences, but they're very, very similar to each other. So first we need to look what select does. And it just pulls data, right? So it's going to retrieve data from the database. Now, if you do select and then you do the asterisk, asterisk is a wildcard character. So it stands for anything and everything, okay? So when you do select asterisk, that means pull everything from users. And we're pulling it from the users table, right? So you have to also close it out with a semicolon. If you don't, it won't work. Literally the entire command will just not work. So this command is going to pull everything from the user's database, meaning it's going to pull their IDs, their usernames, their password, and it's going to pull all of them. It's going, if there were 1,000, it would pull 1,000. If there were, 15 columns, it would pull all 15 columns for every single one of the 1,000 entries inside of this database. Select will tell the database what we want to retrieve. The asterisk tells the database that we want to retrieve back everything from the table. And so it may contain 3 columns. From users, tells the database that we want to retrieve it from the table that's named users. Finally, the semicolon tells the database that that's the end of the query. And that's also very important to keep in mind, because those are the types of things, these are the types of nuanced differences that we will end up using to actually manipulate these queries later on. So now we get to actually do individual things. So if we go over here and we see that there are these fields, we have the ID field, username and password field. We can say, okay, I just want to pull the username and password from the users table. And then it'll bring you only the username and password from the users table, right? So now you're selecting individual fields. So everything is selected, or everything is brought back by the asterisk, right? But then you can do limit 1, meaning only bring me 1 user from this, right? So because again, this right here is pulling everything from the users. So even though it's just their username and password, it's still going to pull all the users. So if we want to just limit to the top 10 or something like that, we could just do that. We could just say limit, right? So it'll pull everything. Or you can just say limit 1, forcing the database to only return 1 row of data. Changing it to limit 1, 1 forces it to skip the first result, and then limit 2, 1 skips the first 2 results, and so on. So it'll skip the first one, return the next one. Skip the second one, return the next one. So if you do limit 2, 5, it'll skip the second one, or it'll skip the first 2, I should say, and return the next 5 entries, okay? So we can do select everything from users, limit 1. So it'll pull all the fields from the user table, and then it'll only return 1 entry. So we can see where the clause itself, this piece right here, the where clause, and we can actually fine tune or finally pick out the data that we actually want. So you can do select everything from the users table where the username field equals admin. So now, because you may not know what row the admin user is actually in, so you're looking for the username admin, and you can even put asterisks before and after this if you're not sure exactly what the full username is going to be. You can really fine tune this. So obviously now it's going to select everything from the users table where that username is admin, and then it's only going to enter that for you, right? This will only return the rows where it's actually admin. Select everything from the username table where the username is not admin. So we talked about the exclamation in the last video. We talked about the exclamation equating to not. So username does not equal admin means what? It'll pull everything that's not admin. So it'll give us entry 1 and entry 3, which would be John and Martin, right? Select everything from users where the username is admin or the username is John, right? Now it's going to pull either admin or John for you. So you can actually do that. That's called an operator. The or that we see right here, it's called an operator. And then you can, of course, use the and operator as well. So this will only return where everything is admin or John, right? So select everything from users where the username is admin and the password is this, right? So it will then require both of these to be true. So when you use and, you're requiring both of these parameters to actually be true. Otherwise, it won't work. It won't pull it. In this particular case, we're pulling anything that could be either one. So or is literally either one could be true, where this one is requiring both of these to actually be true. Now, if one of them was false, it wouldn't return anything to you. In this case, if one of them is false, it would just return the other one that might be true. In this particular case, nothing will be returned if either of them is false, right? So using like allows us to specify if we don't know the exact phrasing of something, right? So instead, it either starts with something, it contains something, or it ends with something. And then you can do that placeholder being percentage. So select everything from users where the username is like, and then you do a, and then you give a percentage. So anything could come after the fact. So if it was admin, it would show up. If it was Adam, it would show up. If it was Amanda, it would show up, right? So anything that starts with an A and then it just follows whatever letters finally. And then so it could be anything that ends with an N, right? So same thing. The first part of the query is exactly the same, where the username like and then percentage N, it would give us John, admin, or Martin, because all of them end in N, right? Select everything from users where the username is like, right? And then you have the percentage at the beginning, percentage at the end. You just know that there's MI in the middle of it. So it could be admin. It could be, oh my God, I'm drawing a blank on what names. Michael could technically actually pull this as well. I think Michael would be pulled from this as well. So anything, essentially any phrase or any username that actually has MI in the middle of it, somewhere in the middle of it. It doesn't have to be exactly in the middle. It could be like anywhere in the contents of that username. As long as it meets it, then it'll pull that information for you. So all of this, these are just different ways that we can query the database and pull data from the database. So now we can talk about union, the union statement that combines the results of two or more select parameters to retrieve data from either single or multiple tables. So this is where the relational table element comes in, right? So when you use union, you can now pull information from two tables. So the rule is the union statement must retrieve the same number of columns in each select statement. The columns have to be a similar data type, and the column order has to be the same. This may not sound clear, but so we can actually use the analogy. So this is the table, right? So we have the ID, name, address, city, and postcode column. And then we have another table, ID, company, address, city, and postcode. So what do we have that's a combination here? We have the ID, city, and postcode. We also have ID, city, and postcode. We also have address, actually. So we have ID, address, city, postcode exists in both of them. The big thing that changes is name is for John Smith, and then company is for the widgets, right? Or the, the names of the companies. The addresses for these are also different, right? Because this is their home information, that's their personal information. This is their work information. So it's the address of the companies that are there. So using this statement, we can actually gather data from those tables. So we're going to select, and this is not a requirement for it to be capitalized. It's just that it helps us determine what is the verb that we're using, or what the actual parts of the query command is that we're using, and then what the values are that we're trying to pull. So it would be select name, address, city, and postcode from customers. Okay, so this is the first table. So select it from customers, and then union select company, address, city, postcode from suppliers. So what will happen? We'll get the name, John Smith, address, city, and postcode. Okay, and then we will also get the name, widgets, tool company, axe makers, as well as their address, city, and postcode. So we're getting the names. Now check this out, right? The name is actually pulling this. Company is technically the name of the company, but it's a different value, right? But it's actually unionizing. It's actually uniting, combining the all of the names, because again, it says company. It doesn't actually say name, but it's being housed under the name value here, the name field, and it's still pulling the information. Insert tells the database that we want to insert a new row of data. So if you actually want to insert it into the users, then you would tell which table that you want to insert it into, and then you would have to give it the actual field values that you are providing. So in this case, it's kind of easier to be able to look at it like this. So we want to insert into the users table, and then we're going to put in parentheses what we're going to provide to the table. We're going to provide the username as well as the password. So we're going to use these fields, and the values are going to be Bob and then his password. And then notice that the auto incrementation, right? So we talked about auto incrementation earlier. The ID field incremented by 1, so it just gave him the ID of 4, but it inserted his name and it inserted his password into it. So insert into users, in parentheses, the fields that you need to actually provide values for, values, and then insert into parentheses the actual values themselves. And then we have update, which tells the database that we want to update one or more rows of data within a table. We can specify the table that we want to update. So we're going to update the table name, and then we're going to set, right? So we're going to set the fields or values that we want to update as a comma separated, so username equals root, password equals this, and then finally, similar to the select statement, we can specify exactly which rows to update using the clause where, right? So update users, set the username to root and the password to pass, right? And so this is the values and the fields, and they're separated by commas, where the username equals admin. So instead of the username now being admin, because it's kind of like a default username that might be with the web application database. So instead of being the default username, and root also is another default username, but whatever. So now we want to set the username value to root and the password value to pass123 in the row where the username equals admin, right? So now the admin user has been changed from admin to root, and the password has been updated to pass123. And then, of course, delete, we're actually deleting the database, or the line of the database, I should say, one or more rows of data. Apart from missing columns you wish to return, the format of this query is very similar. So delete from users, where the username is Martin, and then so what would happen is that it'll just delete that entire row. So delete from users, because no where clause was being used, all the data will be deleted from the table. And that's basically it. It's once you kind of understand the pattern behind SQL, it's really not that complicated. Like, the most complicated stuff was like maybe this one where we were updating it, or maybe the insert, that might be like kind of complicated to think about, or selecting and unionizing or combining the values from, that might be the issue. But apart from that, it's like it's kind of easy to do this. It's not really that complicated to do it. So now what SQL statement is used to retrieve data? And that would be the select statement. What SQL clause can be used to retrieve data from multiple tables? And that would be what? The union clause. And what SQL statement is used to add data? And that is what? The insert statement, right? So let's now talk about, we understand what SQL is, right? We understand what the statements are that we can create. So let's talk about what injection actually is. So what is SQL injection? SQL injection is the point where a web application that uses SQL can turn into this when the actual user provided data gets included in the SQL query. Because typically when you're trying to pull data from, or when a web application is trying to pull data from its database, it will create its own statements. It shouldn't include anything that we would provide to it inside of its query. So that's where we can inject our own request or our own statement into the statement that the server creates for itself. So what does that actually look like, right? So where you come across an online blog, each blog has a unique ID number. The blog entries may be either set to public or private, depending on whether they're public release, right? The URL from each entry may look like this. So website, blog, and then the query is right here. So pull whatever you can from the blog where the ID equals 1, okay? From that, this is what the actual query is going to be that the website is going to run, the web server is going to run. It's going to select everything from the blog table where the ID equals 1 and private is 0, meaning false, right? It's not private, basically, limiting one entry. So from what we've learned, we should be able to figure out what that actually means, right? And I mean, I kind of pretty much explained it to you. So the private column is set to 0, the ID number is 1, which means the table is able to be viewing the actual public and limits the results to only one match. As it was mentioned at the start of this specific section, SQL injection is where we can actually input our own query into the database. So in this particular case, we may be able to do something like this. So this little semicolon dash dash would end up doing something like this, right? Where it would select everything from the blog, where the ID equals 2, right? And now this piece right here, this is where it gets interesting, because remember, we know that if we put a semicolon at the end of the query, or if we put a semicolon inside of the query, SQL is going to say, oh, okay, that's the end of the request. That's the end of the statement. And so this would be the only part of it where it actually pulls it. And then this rest of the elements will end up being ignored. So a semicolon in the URL signifies the end of the SQL. And the 2 dashes causes everything afterwards to be treated as a comment. By doing this, we are in fact just running this specific query. So it's now ignoring a key piece of, or 2 key pieces of information. One of them is, oh, privacy is now turned off, right? So we don't want the stuff that's not private. We want the stuff that is private to be presented to us. And I don't care how many you return to me. I want you to return everything you can. So it'll return an ID of 2, whether it's set to public or not. And this is just one example of SQL vulnerability, and it's called in-band SQL injection. There are 3 types: in-band, blind, and out-of-band, and we're going to be talking about them right now. So what character signifies the end of a query? And we already talked about this. That's semicolon. Very, very important, because that's where a lot of this stuff becomes more functional and practical for us as pen testers. So let's now talk about in-band SQLi. In-band SQLi is the easiest type, and it just refers to the same method of communication being used to exploit and also receive the results. So for example, you exploit it, right, on a web page, and then being able to extract the data from the database to the same page. So it just displays it onto the screen for you. Error-based SQL injection is the most useful way to easily obtain information about the database, because error messages are printed directly to the screen, and they can often be used to enumerate a whole database. Union-based SQL is the type of injection that utilizes the union operator alongside a select statement to return additional data. And this is the most common way of extracting large amounts of data via the SQL injection. And so the practical in this particular case has to do with the virtual machine that's been assigned to us in this free room from TryHackMe. So each level contains a mock browser and also SQL query and error boxes to assist in getting the query's payload correct. So we may need to refresh the page once the machine starts if you get a 502 error gateway. So just keep that in mind. If you have an error, the bad gateway error, you might need to just refresh the page. Level 1 contains a mock browser website featuring a blog with different articles, which can be accessed by changing the ID number. The key to error-based SQL is to break the code's SQL query by trying certain characters until an error message is produced. These are the most commonly single apostrophes and also quotation marks. These are the most common to try to get errors, okay? If we type an apostrophe after the ID and then press enter, we'll see that there is an SQL error. The fact that we've received this message is confirming the existence of an SQL injection vulnerability, because it's actually processing what we entered into it, right? We can now exploit this and use the error messages to learn more. So the first thing that we want is to use the browser without displaying an error. First, we want to get union operator so that we can receive an extra result if we choose it. So if we do the mock browser ID parameter to 1 and then union select 1, this should produce an error message informing that union select has a different number of columns than the original select. So let's try it again. So we'll do 1 and then union select 1 and 2. So now again, same. So 1 and 2 and 3, right? Now it says the success has gone because the article is being displayed, but now we want to display the data instead of the article itself, right? So the article is displayed because it takes the first returned result somewhere in the website's code. To get around that, we need to first query to produce no results. So this can be done by changing the article ID from 1 to 0. So if it has no ID, that would kind of give us an error. So it's just made up of the result with the union select. etc., etc. I feel like I should actually just do all of these things so that we can get to the end of it instead of just reading through it. So here's what I'm going to do. I am going to zoom out of this a little bit so that we can actually load our screen, our split screen right here. And then I'm going to open this up in a separate browser or a separate screen on my secondary monitor. And then from there, I'll read through the instructions and then we'll just manually run all of these exercises together, okay? So that way we can actually kind of do a demonstration instead of just reading through the text. So here's the actual browser itself. This is the level 1 stuff that they were talking about. So the first thing that we're most interested in here is to first just do the error message stuff that they're talking about. So if I go ahead and what is it? So it says if we choose it, or what is it? I'm sorry. At the very beginning, it says try to break the code by putting certain characters and see what is shown up here. So we have this right here. That's the query. And if I just do a quote or an apostrophe, it says syntax error or access validation. You have an error in the SQL syntax. Check the manual that corresponds to your SQL server. At line 1. So now this is what the query is that's going to be presented, right? And so SQL select everything from the article where ID equals 1, and then now we see that the apostrophe is also at the end of it. So okay, interesting. So now we're going to see what we can do without displaying some kind of an error message. So if I do instead of just doing that apostrophe, if I do 1 and then we would do union, right, select 1 like that, press enter, it'll give me an error message. The statements have a different number of columns. Okay, so union select 1 and 2, and still different number of columns. Okay, 1 and 3. Okay, first article, there we go. Now we actually received that data. So 1, 2, and 3 actually worked, and this was the query, right? So select everything from the article where the ID equals 1, and then union select 1, 2, and 3. And so now we can see that we were able to retrieve the data, right? So because, excuse me, you will see that the article is just made of the result from the union select returning column values 1, 2, and 3. And we can start using these return values to retrieve more useful information. So now we want to get the name of the database. So we can do ID right here will end up being 0, right? Now we want to kind of mess around with this a little bit. So if we do 0, 1, 2, 3, let's see what this returns. Now it just gives us the actual, what is it? It'll give us the website to give us no results, right? Because we want to try to find other information, for example, the actual contents of the article or the name of the other tables that might exist. So if we do 0 for the article ID and then union select 1, 2, and 3, we can now see that it's kind of basically not giving us anything, right? It just gives us the it's almost empty, but not really. It just shows that article 1 and then there's empty. So okay, so if we do union select 1, 2, and then this is the next piece of instructions that we got. Union select 1, 2, and now we want to try to pull the database name. So if we do that and just give it an empty parentheses, right? So if we do values 1, 2, and then instead of the 3, we just put the database value itself, or the database field name, I should say, and then just do empty parentheses. Now we have an actual name right here. So now we know that SQLi _1 is the name of the database that's useful to us. So the next query should now get us the list of the tables that should be inside of this database. Okay, so ID still is going to end up being 0 because we want to not pull anything from the current database. We're trying to pull everything from this other database that we have over here. So ID is going to end up being 0. We're still going to do union select, and then we're going to leave the 1 and the 2, and then this last portion is what we're going to end up changing. Now this is a new command or a new option that we're learning here, which is the group concatenation command. So it's group concat, and then we give it the table name, so concat the table name value for us from, now it's gonna, you know, don't lose your mind here. So let me just make sure that this is all good. From, okay, information underscore schema dot tables, okay, where the table schema equals SQLi underscore 1. Okay, that's a lot, I understand. So let's first look at the very first piece of this. The first piece is the group concat portion, this piece right here, the group concat portion. This is the piece that gets the specific column. So in this particular case, we want the table name, okay? So it's gonna get the specific column from multiple returned rows, and it will put it into one string that's separated by commas. The next one will be information schema. So the information schema database portion, this one right here, that is where every user of the database that actually has access to this, and it contains information about all the databases and the tables that the user has access to. So it's actually going to pull the stuff that we should be permitted to access. And in this case, we're interested in getting all the tables in the SQLi1 database that we actually have access to. So if we press enter on this, we should be able to see what we have access to. So if I do that, now it says, okay, we have access to the article table and we have access to the staff users table, which, okay, staff users is actually interesting to us and it's useful to us. Okay, so cool. Now we've gotten some interesting information. We went from first just being able to pull articles and seeing if there's articles available. Then we were able to see if we were able to combine the two tables by just figuring out, all right, so if we do 1, 2, 3, we'll be able to combine the two tables. Okay, so two tables actually do exist. Then we changed it to the ID equaling 0, and then trying to actually find the name of the table, the secondary table that we might have access to. And that's where we did the ID 0. So yeah, so it was ID 0, union select, and then we did 1, 2, and then we tried to just pull the database, the name of the database, by actually referencing database with those empty parentheses. Okay, up until that point, pretty basic, and we were able to find the name of the table, which was the SQLi1. That was the name of the database, excuse me, that we found. Then we did the pull where we're like, okay, well, what tables exist inside of that database that we actually can get access to? And this is the command that was able to give us access to that, this portion where we group concatenated for the table name, right? And then from there, we were able to pull from the information schema of the tables. So information schema is going to be something that you'll see that will be the most generic, and then we can go into table schema and so on and so forth. So that's what we're going to end up doing next, right? So we're going to continue from here. So we're going to now go from table name, and we're going to still do concat, right? So we'll still do the group concat. There we go. And in this case, now we want to get the column name, okay, from the information schema columns. So previously was information schema tables. So now we're pulling the column name from the column schema, excuse me, where the table name is what? Staff users, because that's the one that we're most interested in, right? So staff users. There you go, just like that. Press enter. There we go. Now we actually have the column names inside of the staff users table, or yeah, staff users table. There you go. I need to make sure I get the proper terminology for you. So we first found the database. It was the SQLi1. And then inside of that database, we did the information schema.tables to find what the tables were inside of that database. And we found the articles table, and we found the staff users table. And this command that we're looking at right now is now going to pull the column name. So we found the table, so now we want the column names inside of the table from the columns schema, where the table name is actually staff users. And we were able to now find ID, username, and password being the columns that actually exist for us. Great, so now we just need to go ahead and try to find the actual values of those elements. So same thing, right? So we're going to do this. We're going to go back to group concat. So start from the top. Let me just make sure I can actually delete this. I don't know why it's not deleting. Let's see if we could just do this like this. So we'll do this. There you go. Okay. All right, so group concat still, right? Now we're going to do this. We want the username, right? And we'll do this. We're going to do a concatenation tactic right here where we'll do apostrophe, colon, apostrophe. So we're just manually entering a colon. And then we want the password. Okay, so we know that there's a username. We know that there's a password. We don't want them to be connected to each other where we don't know where one begins and one ends. So that's where we put the manual colon right here, just to be able to separate between the username and password so that we know where one of them begins and the other one ends. Okay, so far we're good over there. And then the separator itself, separator. So let me just do this, separator. And then inside of apostrophes again, we'll do BR and then like that and like that, which would be the HTML tag that forces a separate line. So a new line, right? Line break is basically what that does for us. So this is going to be the full group concatenation query that we're submitting. And now we just want to pull this from the staff users table, because that's where we know everything is. So we're pulling the username and we're going to separate it by a colon to make it human readable. And then we're going to pull the password, and our separator between all of these entries is going to be a new line, which is where this is an HTML tag for a line break. So that's what our separator is going to be. So anytime that it detects that, it's just going to create a new line for us. And then from there, boom, from staff users, press enter. There you go. Admin is password, or so admin username has password. Martin username has password with $2. Jim has work123. Okay, great. So we were able to pull the information that we need. So now we should be able to get access to the username or the password that we would need to actually get ourselves to the next level, which is whose password do we need? We need Martin's password to be able to get to the next level, which is this thing right here. So we can now go, what is the user Martin's password? It would be PA and SS like that, word, and then press check password. And now we're good. So boom. Okay, so there we go. This is the flag that we need to complete level 1, which is, where is it? Right here. So in-band SQLi, level 1, the flag is right here. There we go. THM SQL Injection 3840. So now we're good to move on to authentication bypass for our next attack. So this is where it's going to get a little bit complicated, and I'm going to give you fair warning because I don't want you to be shocked, okay? Previous exercise that we did, we were actually getting the response from the server, meaning the error messages from the server on the screen. Blind SQLi does not give us those error messages. But in this particular case, what we're going to get is we're actually still going to see whether or not the injection was successful, right? So as long as we get some kind of feedback, it should still be relatively simple for us. So blind SQL authentication is when bypassing authentication methods such as login forms is very useful. So we aren't that interested in retrieving data from the database now. We just want to get past login. Login forms that are connected to a database of users usually do this. So you go ahead and submit your username and password, and then it goes and checks the database of usernames and passwords. And if it exists and they match, then it'll actually grant you access. That's what happens with a login form. You put in your username and your password, you press enter or you press login, and then the information you submitted, the server goes and checks against its database, and they're like, oh, for the username Hank, the password is password. So the query that's submitted, it says, select everything from the users where the username is Hank and the password is password. And so as long as those two things actually match, both of them have to exist. When those things actually match, then you get granted login, right? So in the content of the username and password, but more in whether or not the two make a matching pair in the users table. This is where authentication happens. The web application is asking, do you have a user with the username Bob and the password Bob123? The database replies with either a yes or no, or a true or false, and depending on that, whether or not you get access to the login or not, right? So taking that information, it's unnecessary to enumerate valid username and password. We just need to create a database query that replies with a yes or a true, right? So you don't necessarily need the actual username and password. You just need to get a response from the server that says yes, right? So level 2 of this will show us this example. The box is going to be called SQL query, where we can actually see right here, right? So this is where we actually see where everything is being input. And this is what we have as the username and password. So where am I? Right here. So the database is going to be doing this. Select everything from users where the username equals username and the password equals password, limiting 1. The username and password values are taken from the login form fields, and the initial values will always be blank because these fields are currently empty. So to make this into a query that always returns a true, we can always do this. We end it. So this is where that single apostrophe comes in. And then we say or 1 equals 1, and then we give it the end of the command itself by doing that forced semicolon, and then everything after the fact will end up being a comment. So it'll turn this where the username is this and password is this, or the 1 equals 1, and 1 is always going to equal 1. So that will be a true statement. So basically what we're asking the database is either this needs to be true or this needs to be true, and 1 will always equal 1. So the response to that will always be yes, true. So that's how we make sure that this is being done. Now, the key element, one of the key elements here, is this initial apostrophe, because you can see that the password right here has that, right? It has that single apostrophe, and then we need to close the apostrophe. So this is what we get right here. Boom, right here. So it says, select everything from username, da 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 da, where this is this and the password is this, and it already has the 2 apostrophes. And we want to make sure that we comment out that, but we still want to close this out so that the system doesn't think that we don't know what the hell we're doing. So if we go over here and we do a single apostrophe, right? And then we do, let me actually even just single apostrophe, press enter, and see what happens. Okay, excellent. So it's actually not in the upper portion that it would work. It's inside the password field that it would work, because I just added a single apostrophe, and we see that it added it to this piece right here. So in the single apostrophe right here, now I can actually do this. I can do space. There we go. We see that. We can see or. There we go. 1 equals 1. We can see that. Now we're going to do semicolon to imply that we've ended it. And then everything after the fact is going to be a comment. So the rest of this piece right here is all just commented out, and this is now the actual full query that we've gotten access to. So now we're just going to do login, and there we go. Now we're actually in level 2, SQL Injection 3840, and that should be, excuse me. So now I need to click level 3 to get to level 3. There we go. So SQL Injection 9581. And there it is, SQL Injection 9581. So that one was super, super simple, right? It's just a very interesting misconfiguration that we take advantage of, and we were able to pull it off. And now we actually don't get to see a pre-made SQL query for level 3. So this is going to make it even a little bit harder for us. Boolean-based SQL injection, and this is still blind SQL injection, refers to the response that we receive. So a Boolean would be either a true or a false, yes or a no, on or off, 1 or a 0. So any response that can only really have 2 outcomes. And that outcome will confirm that the SQL injection payload was either successful or not. That's basically it. When we look at this, we'll see that the limitless responses can provide information still, right? Or these limited responses can provide information, but with these 2 responses, it's still possible to enumerate an entire database. So on level 3, this is what we're looking at, right? On the machine, we're presented with a mock browser with the following URL that we can see right here. Username equals admin, right? And it says what? True. So the username does equal admin in this case. The taken true API endpoint replicates a common feature that found on many sign-up forms, which checks whether a username has already been registered to prompt that the user should choose a different username. So if it says taken true, it means that that username is already taken. So that means that admin does exist, right? So we can assume that the username admin is already registered, and we can confirm this by changing the username from admin to admin123, and it will then change it from true to what? False, ideally, right? So it says taken false. So this username is not taken. That means that admin123 does not already exist, right? So this will be what the query is going to turn to be. So do we actually even have the query at the bottom? Oh, we do. So select everything from users where the username equals admin123 limit 1. So great. So we can actually see that. So selecting everything from the users where the admin is that specific username, right? So the only input that we have control over in the username query string, and we'll have to find this to perform the SQL injections. Keeping that the username is 123, admin123, we can start appending this to try and make the database confirm true things, changing the state of the taken field from false to true. So for example, if we do admin123, union select 1, right? So establishing the number of columns on the tables, which can be achieved by that union statement to see if it'll actually return true or false. If the web application responded with the value of taken as false, we can confirm that this is the incorrect value of columns. So we keep trying, and we can confirm that the answer is 3 by getting to 1, 2, and 3. Now that the number of columns has been established, we can work on the enumeration of the database. And the first task is to discover the database name, and we can do this by the built-in database method that we previously did before as well. So all of these things I'm going to actually start doing, because instead of just reading through it, this would be fun. This is much more fun if we actually start implementing all of these things. So it started with the admin123 portion, okay? So yes, admin123 is not taken, or no, it's not taken, I should say. So okay, so we have that, great. And we can see that the query at the bottom has changed into that. So let me see if I can kind of keep it so we can actually also see the query at the bottom. Okay, so the admin username is 123, so we can actually see that. So if I can go ahead and do this then, or let's see, if we do username equals admin123, and then if we do, let's see, nope, that's going to do that. So we'll do a comma, and then we'll do union, and then we'll do select, right, to keep the, there you go, so there you go, excellent. And now we'll do 1, and then semicolon, 1, 1, enter, and now it says taken false. Okay, so it doesn't have just 1, right? So now we'll do 1, 2, enter, still. Okay, great. Let's do 1, 3, comma 3, enter. Okay, now it says taken true. So now we know that, okay, the union to the next table that we're trying to get access to, or the next database, I should say, that we're trying to get access to is, okay, there's a 3-column table that would be the one that we can actually get access to. So now what we can do is we can try to pull the actual database name by following along with essentially everything that we've already established. So all of these things are still going to stay the same. So the admin123 is going to stay the same. Union select 123 is going to stay the same. Then we're going to add some extra stuff where we have where, right? The database, whoops, database, there we go, empty parentheses, it's like, so the database name is like, and then it says S and percentage, right? Or actually, not even that. I should actually be doing the first one is the database name is just like the this piece right here, where we just put percentage first. So we're going to still get true. We've gotten true so far, right? So if I do empty database and then just do percentage in there, press enter, it will also say true. So it says, okay, well, fine, there's also a database name in there. So now technically what you can do is you can go through all the different iterations, and this is going to take a lot of time, so I'm going to kind of skip around with this, but you would again just do all of the iterations to see what the name of the database would start with. So if I do a percentage enter, it'll say no, it's false. It's like, okay, so it doesn't start with an A. If I do B percentage enter, it's false. Okay, it doesn't start with a B. You do C, false. D, false. E, oh, it starts with an E. Interesting. Okay, so we have a database name that actually starts with an E. You see? So just by doing it through trial and error, essentially, we can see that it starts with an E. Okay, I tried all of the other iterations. So I went through the EA and then I went through EB, etc. And it all came back false. But it's actually really interesting that E by itself, oh, you know what? E also just came back. Maybe that was the issue because E by itself came back as false. So I think I misread something maybe because I thought E by itself was true. So E is definitely not true. D would not be true. F would not be true, etc. And we can just move forward. And so based on just the documentation, they kind of did a lot of the work for us. So we can actually just go to S, and then we can see that S, a database name that starts with S, would end up being true, right? And then you can just continue forward and just keep doing the trial and error until you get the full database name. Now, to save time, again, so it would be like this, right? So you would do SA, and it would be false. SB, it would be false, etc. So if we do SQ, because we know that we're going to SQL, right? So SQ, it returns true. If I do SQA, it'll be false, right? If I do SQL, it'll return true. And we can then do SQLa, right? And keep going through those iterations until we find the appropriate one. Now, this particular one, the next character is actually supposed to be the underscore. So it would be SQL underscore, which would give us a true. And then so now it would be SQL underscore A, right? And that would be false. SQL underscore B, etc. So we would then go to T, which would end up being SQL underscore T. Now it's supposed to be, or excuse me, actually, SQL underscore by itself is true. But what we're looking for is not SQL underscore by itself. We're actually looking for SQLi underscore. There we go. That's the one that we're supposed to be kind of working our way towards. I kind of jumped the gun a little bit. So SQLi, SQL injection, that's kind of what we've been working on. So that's the one that is true. Then there's the underscore, which would also give us true. And then there's the letter 3, which 3 would give us true. And then if we went TA, it would be false. So we would end up with TH. Okay, so it's true. THA, it's false. Then we would keep going until we ended up with THR. Okay, so that's true. Then I could be like, okay, so maybe it's the word 3. Oh, we're looking for the word 3. Oh, okay, so there you go. SQLi 3 would end up being the database name that we're trying to find. So this specific one is more time intensive than anything else because you have to actually go through every iteration of the characters that are available until you actually find some legitimate names. So SQLi 3 actually is the database name that we're interested in. SQLi 3 is the database name that we're interested in. And if we really want to test it, we can actually now move this last element off and just leave it as that. So we're just going to say we're looking for a database that has SQLi 3, and that should be giving us true by itself. So if that gives us true by itself, that means the database name actually is SQLi 3. There is no other characters or anything that we're missing. So now we have the database name, which is great. So now that we have the database name, we can move on to the information schema, where we pull the table names, and then where the information schema where we start pulling the column names. And again, we're still going based on the true and false responses that we can potentially find. So union select 1, 2, 3, it's going to stay. Where is going to stay. So actually, excuse me, where is now being moved. So we're getting rid of where. Sorry about that. And we're still leaving the last piece, right? But the semicolon dash dash, we're still leaving because we want to still comment out the rest of this. So now we're going to try to pull from the information schema. So it would be from information schema, and we want the table names first. So we're going to be getting tables where, right, the table schema, okay, equals the actual table name that we just found, which is the SQLi 3. So that's it. And the table name is like, so table schema being what? The actual database name is what we found. So we're pulling from SQLi 3. That's, we know what the database name is. And then now we have to go through the same exact process that we went through before to try to find the database name, which is what? You put the quote, you put the percentage sign, and then you close it out and you press enter. And you say, okay, cool, there's a table name in here. All right, so if there's a table name, does it start with an A? No, it doesn't. Okay, does it start with a B? No. C? No. D? No. And then you just go through all of the letters until you find the one that it actually starts with, right? So once we get to U, press enter. Oh, it's true. Okay, great. So UA, right? And then nope, that's false. UB, and then that's false. So you just keep cycling through that until you get to US. And it's like, oh, that's also true. Okay, great. So USA. Nope, that's false. USB, nope, that's false. And then you go through that until you find USE, and that ends up being true. Okay, great. USEA, right? It's false. And then you end up until you get to USER, so user. Okay, great. That's true. So, and then you again keep cycling until you get to the point where you end up with USER, let's say A, it's false, so we can do USERS, and that's true. So then we can confirm whether or not this is the official name, right? By deleting what? That percentage sign and then checking that. Okay, great. So that's definitely in there. So what if I just did this? I remove like and I do table name actually equals users. What if I did that? Press enter. Yep, that's also true. So, okay, great. The table name does equal users. So now we have table schema from the tables that we've pulled that we know that the SQLi 3 is the actual name of the database. And then we also have the table name being users. So now we definitely know that we actually have the users in there. So now we need to start enumerating the columns in the users table so that we can properly search it for the credentials, and then we can use information schema. But now since we're doing information schema columns, we're not doing tables anymore, right? So we're going to go all the way at the beginning of this, or not the beginning, I should say, like kind of towards the end. So let me just make sure that I can actually highlight this thing. For whatever reason it's not. There we go. Okay, so information schema is what we're looking for now are the columns, right? Where the table schema information that we're pulling for is going to equal what? SQLi 3, that's the database that we're searching through, and the table name, right, equals, equals users, because we know that that's what our table name is, and, right, here we go again, because it starts again, the column name is like, and then start it again, A, percentage, close it out, press enter. Nope, there's no column name that starts with an A. Okay, does it start with a B? Nope. C? Nope. So then you literally go through this. This is like very painstaking if you haven't already imagined, because you have to actually now do this for every single one of the columns. So you need to find, all right, column name number 1 is ID. Column name number 2 is whatever, name, I guess. And so it just keeps going and going until you actually find all of the column names. So we'll have to cycle through all the letters and the numbers and the characters until we actually find a match. Now, in this particular case, because we're actually looking for multiple results, every single time that we come up with one, we need to find the new column name and avoid discovering the old name. So for example, the one that we're looking for is obviously ID, right? So column name like I, it says false, which is silly because it's not supposed to be false. So column name, am I misspelling column name or something? Table name is users, schema is 3. Okay, so this is all good. So A, no, I should not be false. It should be true. Oh, because I have an extra quote at the end of this. So I'm going to do I percentage, enter. There you go. That's what it is. So There we go. I had an extra apostrophe at the end of it. So it does start with I. Great. So ID, does that work? Yep, we have ID. So we know that we actually have one column name that's at least ID, right? So now we can look at the full query. This is what the full query looks like, right? Everything after admin123, this was false. So we added an extra apostrophe. Then we did union select 123 from information schema columns, where the table schema is SQLi3, so that's our database name, and the table name is users, and the column name now starts with ID. So that gave us a true response. So far we're making decent progress here. So now that we know that the column name, there is actually a column name named ID, because we've established that. So I can even do this, right, just to again confirm. I can get rid of that percentage sign and then do column name equals ID. Do that and it still gives me true. Okay, great. So now I know for a fact that there is actually a column name that's named ID. So what I need to do now is do the same thing, but at the end of it, we're going to add an extra addition where the column name is not equal ID. So I want to discover a new column name, okay, but I don't want it to discover the same column name as I did before. So the entire thing will stay the same. The entire query will end up staying exactly the same, but we're just adding an extra portion where we're searching for the second column, and we just don't want the column to be named ID. So we're going to go through this again, right? We're just going to start here again. And before the column name equals ID, before this part, we're going to do another one. So right after users, we're just going to start another one, and it says and column name, okay, is like, again, a percentage close enter. It's false. Okay, so the second column name doesn't start with an A. Does it start with a B? No. Does it start with a C? No. And then we'll just keep cycling through that, right, until we can find the next one specifically, which in our particular case, I think it's going to be username and password. So if it starts with a U, should be true. Great. So if it's username, right, so let's just skip to the end here. You should already have the pattern down by now. So if the column name equals username, but it does not equal ID, tell me if it's true. And it is true. Great. So now I'm going to move on to this one. Close that one out. So column name does not equal username and it does not equal ID. So I want the next one to be column name, and then we need to find another one, right? So column name is like, and then we'll start it again. We'll do a percentage close apostrophe, and the column name is not username and it's not ID. So you can see the query is getting pretty crazy over here. So does it start with an A? Nope, it doesn't start with an A. Okay, so let's say we already know if there is a username, there needs to also be a password. So does it start with a P? Oh, it starts with a P. Okay, so password. Oh, that is also true. All right, so let me just make sure that column name itself actually does equal password. That is also true. So now we know for a fact that inside of the SQLi3 database, there is a table named users, and there's a password column, there's a username column, and there's an ID column. Because all of this whole thing returned true to us. So that's a very long query that we just created, but that statement, every element of it was true, meaning all of those things actually exist for us. So that's great. So now we know we have ID, we have users, we have the SQLi database, we have the users table, and then inside the users table, we have ID, username, and password. So now we can actually pull from that users table. So from here, so we can actually just delete all of this shit except that last piece with the comment. So we can come over here and we're going to go union select columns 1, 2, and 3. Okay, great. We're selecting it from the users table, right? Because we know that it exists. Where the username, now we need to go through again the same process, is like, right, a percentage close. Oh, cool. There is a username that starts with an A. Okay. Does it start with an AD? Yes, it does. Okay, great. Does it start with an ADM? Yes, it does. Oh, let me guess. There's a username called admin. Of course there is. All right. So let's remove that percentage at the end. And then instead of doing username like, we'll do username equals. Oh, there is an actual username that's named admin. Great. Okay, cool. Now we have the username admin. All right. So we're going to pull from the users where the username is admin and the password, right, is like a percentage, close it. Nope, password doesn't start with an A. Okay, B. Nope, okay. So we'll just go through this. And then what's going to end up happening is that towards the end of it, we'll have to go through all the numbers. So does the password start with a 3? Oh, the password starts with a 3. Okay, does it start with a 3-4? No. Okay, does it start with a 3-8? Oh, it starts with 3-8. All right, so is it 3-8-4? Oh, it starts with 3-8-4. Is it 3-8-4-1? No, it's not. Is it 3-8-4-5? Oh, it is 3-8-4-5. Okay, great. So now let's see. And then again, you'll run through all of these things. And this is what's really crazy, because then you'll be like, okay, so is it 3-4-5-A? No. All right, so is it 3-4? And then you'll run through all of them. And then you'll get a false statement for everything else, which implies that, okay, it's not 3-8-4-5-7. It's not 3-8-4-5-J, right? Like you'll run through all of the options and you'll get a false for everything else, which means that what? It actually is 3-8-4-5. So we can then delete that percentage at the end. We can come over here and say the password equals 3845. Okay, great. So it is actually, the username is admin and the password equals 3845. So now I know for a fact that that's what my login is going to be. All right. So let's just log in as the admin user with the password 3845. And the login should actually be successful. And now we have gotten to level 4. So the flag for level 3 was the SQLi injection 1093, as we can see right here. So that one was like the most painstaking. Like if you're actually doing this in real life, if you're doing it in the real world, you literally will have to go through every single iteration until you actually find the answer. And this is where scripting comes in. This is where creating a script that can actually go through every single letter and every single character and all of those things, and then find the ones that finally gave you a true response. That's where it comes in. And very, very freaking useful if you know how to create Python scripts, or if you know how to create shell scripting or anything that can actually do these type of work for you. Because if you can imagine, it's going to take you a very long time to try to do this manually, letter by letter, sitting there one by one. Now, if you are forced to do it manually, now you know what you're doing. And the fact that you actually need to know that this is what the process is will allow you to create a successful script that will actually be able to find it for you. But if you didn't know what you were looking for, or if you didn't know what the process was, then you wouldn't be able to find the script. So that's where, or you wouldn't be able to create the script, excuse me. So that's where it actually comes very handy to actually go through the manual labor of this, so to speak, to be able to find what the process is, so that then you can go ahead and write a script that will create the automation for you, or at the very least go to your favorite AI and be like, hey, I want you to write a script that will do this, right? I want you to go write a script that will go ahead and find me the username, and then go ahead and find da-da-da-da-da-da, and then manually find, or, you know, quote unquote manually, the script will go ahead and find it for you. All right, so let's go to the blind SQLi that would be time-based. Time-based blind SQLi is similar to what we saw previously, because it's now, we're just essentially looking at a time as the indicator of whether or not we got something right. So the indicator of a correct query is based on the time that the query actually takes to complete it. The time delay is introduced to using a built-in method like sleep alongside the union statement. The sleep method will only ever get executed upon a successful union select statement. So for example, when we're trying to establish the number of columns in a table, if we use this, if there was no pause in the response time, we know that the query was unsuccessful. So like on the previous task, we add another column, so on and so forth. So if there is no pause, we know that it's unsuccessful. If there's a pause, that means it is successful. So let's actually go ahead and try these two out, these two that we have over here, that will hopefully kind of show us what it is. So if I go over here, the query is at the bottom right here, and so it'll even show us what the time is, right? So if I do admin, or what is it, refer is TryHackMe, and I guess I would do admin, and let's see what shows up at the bottom right here. And it does have that at the bottom. So admin, that kind of doesn't seem to be appropriate here though. If I do comma or apostrophe, I do admin, would that be the case? Because it seems like that's not the right thing to do. So when trying to establish it, you would use the following query: admin123 union select sleep 5, and then see if it'll actually work. So I'm just going to type it as they said it. So admin123 apostrophe and then union select sleep, and we would do 5 and then close it out, and then we would do the 2 dashes. So this is what we see right here. But domain does not, it's not supposed to be domain admin TryHackMe. I don't think that's what it's supposed to be. So I don't think this is actually going to work. So if I do this, it will give me, yeah, it's not a pause. There's like no pause that's taking place. Okay, so if I do the next version of this where they're implementing that, they would say do a second column and press enter. Okay, I guess this works. So now the requested time was 5 seconds. So the sleep 5 worked, which is really odd because the way that the SQL query from the bottom works, it's kind of weird. It doesn't look right to me, but I guess that actually works. So the payload should have produced a 5-second delay, which it did, confirming the successful execution of the union statement. Now we can repeat the enumeration process from the Boolean based injection, adding the sleep method to the union select statement. And if you're struggling to find it, this will help us get started. And this is insane to really think about, because we have to go ahead and iterate through all of these things, right? So we have to go through, iterate through all of these things to actually start from the very, very beginning. So it would be, okay, union select sleep 5, comma 2, where the database, right, is like, and this is what they're giving us as a starting point. So this is what the manual portion of this should be. So this is giving us the database is like, comma u, which I guess it isn't, right? So database does not start with a u, I would say. And let me see if the rest of this, yeah, the rest of it is fine. So union select sleep 5, where the database starts with a u, and it doesn't. So let me see if I can get, I'm obviously going to cut through this because there's no other hints that they're giving me here. They're literally just saying that this is where you should start with, and then see if you can find the database name, and then go find the table schema and all of that, which is, my goodness, it's going to take a long time for me to do manually, but I have to do it. So I would very much like for you to also try this before you finally get to the portion where I give you the answer, because I'm going to go through every little step until I find the answer. But try to do it a little bit yourself. But I understand if you just want to skip and kind of find the answer to the end. But hopefully you will at least try it, because I want you to get the process under your belt. But anyways, by the time I'm going to pause, and then in 1 second, you're going to see me with the answer. Okay, so quick little update before we move forward. So the key element that I have changed here is, number one, there is something that they did mention, which I don't know if this actually really makes that big of a difference. Oh, it's still on this page. So right here, they did say that we can start it with refer equals admin123. So it doesn't actually say TryHackMe over here under the domain. So it actually just starts with admin123. So that's the one piece that it's like right after refer, I started with admin123. And then I ended up with users, because I just kind of assumed that we're looking for the users table, because it says this is where we should help you on our way. Database starts like users, so, or it starts with a U. And so that's kind of where I immediately jumped to that conclusion, where I was like, okay, well, it's probably a user's database that they're looking for. So union select sleep, I changed it from 5 to 3 because I don't want it to take 5 seconds each time that I go through it. It'll be a little bit faster for me. So it did update that, and the rest of it was, okay, so after this part, it's pretty much the same, standard, like very similar other ones. And now it says from users, because now I guesstimated that it was users, where the username like A, and so we're starting with that now. So now we're going through the username starting with an A. So if it is admin, all right, so there you go. Now it's going to lag another 3 seconds for me. There you go. So it did take 3 seconds. So the username is most likely admin. So we can go ahead and remove the percentage. And then from here, we can just say where the username equals admin. And it should take 3 seconds again, which it is. So great. So the username definitely does equal admin. And then we can just go here and then say and password, right? Password equals, or I should say is like. And then from here, we'll start from scratch. And so we'll do, you know, a percentage and then close that. And then it'll take 0 seconds. So this, now I need to go ahead and kind of work through the password itself to try to find what the password would be, and just run through whatever password options we might have. I think it might be easier if we start with numbers, because the last one, the password was actually numbers. So if we go here, oh, there you go. So there's an actual lag right there. So, okay, so the password does start with a number. So it starts with a 4, and then we can now just go through all the numbers to try to find what the potential password would be for this guy, for this admin person. And hopefully it won't take forever. Oh, there you go. So it starts with the 49. Okay, there you go. I'm just going to go through the iterations real quick, and then we'll find the password, hopefully soon. Okay, so we got a 4-digit password so far, and it's 4961. So let's see if it actually is 4961. And it looks like it is. So the username is admin, password is 4961. This is what the full query is, if you want to actually kind of pause and look at that. So let's see if we try to log in with admin with the username 49 or the password 4961 and correct login. Okay, great. So it actually worked, and there we go. So that's the last flag, the SQL Injection Master. This one, they really didn't give us much to go with apart from this piece where they're like, okay, you can start it with this. The sleep I just changed into 3 just to make it a little bit faster. And the database, like this part, I skipped this piece, because if it starts with you, because they said this would help us. So if it starts with you, I was like, okay, we're probably looking for users, because we're looking for a username and password to be able to log in. So I was like, all right, so we're looking for users. So I just changed the rest of it where, okay, the database, or where the, from here where he said from users, right? So that's where we went to. And then from users, we then went, okay, where the username equals, and then I started working to that. And then again, it's like guesstimation, right? I'm trying to find most likely an admin user, and then most likely the hardest, like the longest part of it ended up being the actual going through all of the numbers to try to find the numerical 4-digit password for the admin user. So let's talk about out-of-band SQLi now. Out-of-band SQLi is not as common as everything else that we've talked about so far, and it depends on specific features that are enabled on the database server or the web application's business logic, which makes some kind of external network call based on the results from the SQL query. So it's going to reach outside of its internal server. It's trying to connect to something externally outside of itself, right? The out-of-band attack is classified by having 2 different communication channels. One launches the attack and the other gathers the results. So the attack channel could be a web request, and the data gathering channel could be monitoring the HTTP DNS request made to a service that you control. So this could be potentially Netcat. It could be running Wireshark and just capturing traffic, or TCP dump to capture traffic. So the attacker makes a request to a website that's vulnerable to SQL injection with an injection payload. The website makes an SQL query to the database, which also passes the hacker's payload. And the payload contains a request which forces an HTTP request back to the hacker's machine containing data from the database. So this is what it looks like. This is the hacker. This is the lowest quality graphic they've created so far in TryHackMe. So this is the hacker. Step one, they make the request to the website. The website tries to connect to the database, and the database reconnects to the hacker. This is the lowest quality image that they have created by far so far. But essentially, the request that's being submitted is where that injection payload would actually exist, so that when the website passes the injection payload to the database, inside of that is where the remote connection back to the hacker's machine or his server would end up being. So this is what's called an out-of-band attack, where it's outside of the internal web server, and we need to have some kind of a HTTP connection or a DNS connection to actually receive the response from the SQL server. So name a protocol beginning with D that can be used to exfiltrate data, and that would be DNS for the domain name system, the domain name service. So let's talk about remediation. Very similar to everything we talked about with the previous injection techniques and everything else in general when it comes down to injection. The key things that developers can do is to have input validation, also known as sanitization. We can have prepared statements, and this is more specific to SQL. So in a prepared query, the first thing that a developer writes is the actual query, and then any user inputs are added as parameters to the query. So writing prepared statements ensures that the SQL code structure doesn't change, and the database can distinguish between the query and the data. And as a benefit, it also makes your code look much cleaner and easier to read if you are interested to actually go into coding. But the key element here is that all of the statements that would be made to the database are prepared in advance, and then the only thing that's modified inside of those statements are the potential inputs that are added by the user. Now, as long as there are no error messages or anything that can be displayed on the screen that would give the user some kind of a hint on what type of statements are being sent out, they shouldn't be able to modify the statements, right? So input validation would be the next piece that would be attached to this. So it's like you would do all of these things. You wouldn't just do one or the other. Input validation can go a long way to protecting what gets put into an SQL query. Employing an allow list can restrict inputs to only certain strings, or a string replacement method in the programming language can filter the characters that you wish to allow or disallow. Basically, this is sanitization. This is saying that this is what's allowed, this is what's not allowed, and we validate every single input that goes into the server by running it through a pre-approved list of what can and cannot be sent. That's kind of the name of that game. And then escaping user input that contains characters like the apostrophes or the double, the quotation, or the $sign or the backslash. These can cause SQL queries to break, or even worse, open them up for injection attacks. So removing those actually being available or being usable is what's important here. So prepending a backslash to these characters, which then causes them to be parsed just as regular string and not a special character. So this is what that escaping means when you actually do a backslash. And this is also, I think it's very similar to what happens inside of regular expressions as well. Like regular expression patterns, you can escape special characters so that they can be input as literal characters. So instead of when somebody tries to do the single apostrophe, or they try to do the semicolon, for example, if they try to do a semicolon, if we prepend that semicolon with this backslash, then it'll be treated as a literal semicolon, not a character that would end the statement for SQL requests, right? And that's the thing. So it would be a combination of all of these things that you would end up using as your remediation tactics, so that you can make sure that your SQL database and just your server in general is as secure as it can possibly be. And a method of protecting yourself from SQL injection, one of the methods would be known as prepared statements. And that's pretty much all we got. That's all she wrote. I would say this, out of everything that we've talked about so far with web hacking, this is probably the most complex video that we did for web hacking in Junior PenTester. And it's appropriate because this is the last portion of the web hacking module inside of the Junior PenTester training series. So hopefully it didn't drive you insane. Hopefully you were able to gather some of the information and kind of wrap your head around it a little bit. Most of the complicated stuff, they gave us a step-by-step walkthrough. So if you just went through these processes and actually input these commands piece by piece, letter by letter, you should have been able to achieve the same results, whether or not I even gave you any kind of instruction or kind of displayed anything for you. The hardest part was the last one, where we actually kind of had to be like, all right, so I think we're going to be dealing with the users table, and then from the users table, I think what we're going to try to pull is the username and the password. And that was also like, I kind of cheated because I'm like, oh, they're probably looking for the admin, so I skipped to the admin user, and then they're kind of looking for a password, so all we really need to figure out is the password of the admin user. And then thankfully it was just a 4-digit number, which it made life a little bit easier. So I would say this is kind of the most complicated. It definitely was the most complicated out of everything that we've talked about so far. This was the most complicated. So be patient with yourself as you go through this. You don't have to understand it the first time around. This is not something, especially if you've never dealt with SQL before, this is not something that you're going to get the first time around. It took me some time to understand what SQL was. And I think it's important for you to give yourself that grace and to be patient as you go through this, because if you expect yourself to understand it on your first try when you've never been exposed to something like this before, it's unfair and it's going to discourage you and you're not going to want to continue. So this is not meant to be something that you understand on your first exposure to this information, because SQL just by itself is a language that you need to learn how to do and how to interact with databases. And what we're trying to do here is we're trying to hack into an SQL database. So it's like an advanced version of doing SQL. And again, it's not fair if you expect yourself to get it like this, like the very first time around. So that's the big thing that I'm going to tell you about this something. And I should have probably said this at the very, very beginning of the video, but if you've gotten to this point of the video and you're watching this and you're hearing this message, I really hope that you will be kind to yourself and you will be patient with yourself as you go through this process, and don't be critical, don't judge yourself for not getting it immediately right away. But that's pretty much it. We are officially wrapped with Intro to Web Hacking module for the Junior PenTester pathway, and now we can move on to the next module, which is for Burp Suite, and hopefully you'll join us for that as well. If you got any value out of this video, and if you'd like to get more videos like this one, I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. I'm sure you will have questions for this, so if you have any questions, please drop your questions in the comment section below, and I'll try to get to them, or I'll try to give you as detailed of a response as I possibly can in a comment. But hopefully the video itself helped you kind of wrap your head around what was going on. We have a lot of other videos that are going to be coming out in the future weeks and months as we go along. I am going to wrap up the Pentest Plus series of trainings, which is part of the CompTIA Pentest Plus playlist. We have all the other CompTIA resources that are available, and these are all complete. People have taken them to pass their certification exams. Their CySec 101 playlist, if you haven't seen that, that's a very important playlist because it helps you with your foundations. And every Friday, a new video will come out for CompTIA Pentest Plus until we're wrapped with that. And I think it should be wrapped in probably like a month or two. So I think there's like maybe 6 to 8 videos that are left for that specific playlist, and it will be completely done with that. And then there is, of course, the exclusives for Hackaholics Anonymous. We have SOC Level 1, SOC Level 2, Security Engineering. There's hundreds of videos on this channel, and there will be continuing to come out. So this is meant to be an all-inclusive resource for anybody who's interested in security engineering, engineering in general, cybersecurity, and penetration testing, ethical hacking. So this is kind of what my intention is for this channel, and I hope that it ends up being more valuable to you as well. So if you have any comments, drop them in the comment section. If you have any questions, drop them in the questions or comment section below. and make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, especially for Junior PenTester and PenTest Plus. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later.